Hello, welcome to lesson 2 of your geometry series. Today we are going to start talking about lines and linear equations. So you want to find day 2 in your notes packet and fill this in as we go. Or if you don't have a notes packet, just follow along and we will get those answer keys to you later. So when you write the equation of a line, you probably remember this form y equals mx plus b right here. So mx plus b equals mx plus b is your standard form for a line. And actually, it's not called standard form. It's called slope-intercept form of a line. And m is your slope, and b is your y-intercept. And so it's basically a way for you to say, if I want to draw a line, I can start at this point on the y-axis and then go up this much and over a certain amount, being your slope. So it says, use the graph pictured to answer the following. What are the coordinates of the y-intercept? Well, the y-intercept is literally where it hits the y-axis, which is right there, and that's down 3. So my y-intercept is the point 0, negative 3. What is the slope of the line? So what I want to do is I want to connect that y-intercept point to another point that seems like a lattice point. That means it's right on the corner. And it looks like I go up 1, 2, 3, 4, right 2. So my slope is up 4, right 2, which reduces to 2. So the slope of the line is 2, which means the equation is y equals 2x minus 3. My slope goes in front of the x. The y-intercept goes at the end. Ta-da! On the grid above, draw a line parallel to the given line. Okay, so parallel, we said in the previous video that parallel lines have the same slope. So if I want to draw a line that has that same slope, I'm going to get a green point out, and here I'm going to start it up here. And my slope was 2, which means I go up 2 over 1, up 2 over 1, or down 2 left 1, down 2 left 1. And I keep saying over 1 when I really mean up 2 right 1. But sometimes I misspeak. So this green line is parallel to the purple line. All right, what else does it want me to do? Write the equation of the line I drew in part D. So if I want the equation, I should probably identify the y-intercept. And let's see, I went up to 3 above the x-axis, so my y-intercept is 0, 3. And my slope is the same slope as what I started with, which was 2. So my equation is y equals 2x plus 3. And then what is true about the slopes of parallel lines? We've already said it. Parallel lines have equal slopes. Equal slopes. Ta-da! Page 1 done. Now, page 2. Write the equation of each line pictured. Okay, so if I want to write the equation of a line and I want to use slope-intercept form, I need to identify the slope, identify the y-intercept, put the slope in front of x, put the y-intercept at the end. So if I look at this here, my y-intercept is negative 2. And let's see, where's a lattice point? Right there. So I'm going to go up 3, right 1. So my slope is up 3, right 1, which is 3. And my y-intercept is the point 0, negative 2. So the equation of this line is going to be y equals 3x minus 2. Now, this is one of those points where if you feel like you remember linear equations and you don't need to listen to me say this very, very slowly, go ahead and move on. So if you want, you can pause the video right now, do your work, and then kind of scrub forward in the video to see if I'm doing the things that you think I would be doing, and you can check your work. If you're like, yeah, I barely remember which is the x or the y axis, I need more help, then follow along. So I'm going to go through and do a bunch more of these, and we will practice writing equations of lines. So if I come over here, I got another y-intercept, this time of positive 2, and my slope is down 1, right 2. So my y-intercept is 0, 2. My slope is down 1, right 2, so negative 1/2. So the equation of the line is negative 1/2 x plus 2. Now, just so you're aware when you see other linear equations like this, negative 1/2 x can be written as negative x over 2 plus 2. So every once in a while you might see it like that. If the x jumps up on top, it means it's really off to the side with a 1 on top. Okay, so that's completely fine. Let's see, what else? Ooh, vertical lines. So where's the y-intercept? Yeah, there is no y-intercept. Interesting. Okay, so I probably can't use slope-intercept form. So then I need my slope. My slope would be up 1 over nothing. So my slope is like 1 over 0. That's undefined. With vertical lines, this vertical line passes through x equals 3. And in fact, it stays on the 3 value for x the whole time. So, vertical lines always have x equals a number as their form. There is no y in vertical line equations. Horizontal lines, similar but slightly different. If I have a horizontal line, I do have a y-intercept. It's 2, but in fact, that y value is the same all the time. My y value is always -2. I think I said 2 at first. I meant -2. My y value is always -2. So this is just going to be y equals -2. So vertical lines have an x equals equation. Horizontal lines have a y equals equation, where it's just set equal to one number. And if you're thinking, wait a second, can't I still do those horizontal lines with the y equals mx plus b? You can. You don't have to, but you can. Because if I think of this, this has a y-intercept of -2, and this has a slope of up 0 over 1, and 0 divided by 1 is 0. So if I made that y equals mx plus b form, it would be 0x minus 2, but 0x minus 2 really just becomes y equals -2. Okay, you do not need to do it this way, but I wanted to show you that you could. Yada, yada. Okay, E and F, 2 more real quick. In this one, my y-intercept is 0, 0. And up here, just because it's going to bug me, why my y-intercept is 0, -2, not just -2. Here, my y-intercept is 0, 0, and my slope is up 1, right 1. So my slope is up 1, right 1, which is 1. So the equation would be, whoops, hit my finger on the zoom button. My equation would be y equals 1x plus 0, which really just simplifies down to y equals x. When your y-intercept is 0, you won't see a y-intercept in the equation. It's there, but it's 0. And then last but not least, on F, we have a y-intercept of 0, 1. I have a slope of down 1, right 1. So -1 over 1, which is -1. So my equation would be y equals -1x plus 1, which is y equals -x plus 1. Okay. There's linear equations. Now, what if I have to write that equation, but I don't have a picture? I have information. We can do the same thing. So if I wanted to write an equation, just given information instead of the picture, I can do that too. My y-intercept is 3, my slope is 4. Y equals 3/4 x plus 3. Put the slope in front of the x, put the y-intercept at the end. Passes through 5, 6 with a slope of 0. Couple ways to go about this. If it's me, I'm going to sketch a picture and say, okay, passes through 5, 6. That would be up here. Slope is 0. 0 slope is a horizontal line. Horizontal lines have a slope of 0. So I want this horizontal line. And we just got through saying horizontal lines have a y equals a number kind of equation. Well, what does y equal? It equals 6. So that would just be y equals 6. Handy thing to remember, horizontal lines have a slope of 0. Vertical lines have undefined slope. It's silly, but it might work. Horizontal lines have a slope of 0 because it looks like a Z. Undefined looks like the first part of an N. Passes through -3, 4, and it has no y-intercept. Okay, I'm going to sketch this one again here. So -3, 4. And if it doesn't hit the y-axis, that means it must go like this. Oh, that's one of those vertical lines. And vertical lines have an x equals equation. And in this case, x equals -3. All right, on the same set of axes, graph each pair of equations, name the point of the intersection. Okay, so I have y equals x minus 1 and x equals 6. So I'm going to start with this one. If I look at this equation, I should be able to note that the y-intercept is 0, -1, and the slope is the coefficient of x, which has an invisible 1 in front of it. So my slope is 1. So I'm going to start at 0, -1, and go up 1, right 1, up 1, right 1. And try to be as careful as I can here. And then I have the line x equals 6. So x equals 6, 1, 2, 3, 4, 5, 6 would be right here. And so if x equals 6, it's a vertical line. And I graphed it, and it looks like they cross right here. And if I wanted to name that point of intersection, that's 6, 1, 2, 3, 4, 5. And I'm done. Wait, no, I'm not. When you graph lines on a picture, you have to label the lines with their equations, especially if you have more than one more than one equation on one graph. So I would want to come back here and say that this is x equals 6, and this is y equals x minus 1. Now I'm good. 3y minus x equals 12 and y equals 2. Well, now I'm in a pickle. That's not y-intercept, slope-intercept form. It's not in y equals form. I mean, I can graph y equals 2. That's not too bad. That's that horizontal line going through 2. But I really like it when lines are in y equals form. Okay, get it in y equals form. I'm going to take this equation right here, add x to both sides, divide everything by 3. So then I get y equals 4 plus, now x over 3 is like, remember before we had that -1/2 x became like x over 2? X over 3 is the same as 1/3 x. So this is the equation, y equals 4 plus 1/3 x. Okay, so my y-intercept is 4, and my slope is up 1, right 3, up 1, right 3, or down 1, left 3, down 1, left 3. And now I know exactly where they cross, which is 1, 2, 3, 4, 5, 6, -6, up 2. And that's where they intersect. Okay, so that is how you graph lines. Quick wrap up. Make sure you know how slope-intercept form works. Make sure you know how to get something that's not currently in slope-intercept form into slope-intercept form. And remember, if you have y equals a number, that's horizontal and it has a slope of 0. If you have x equals a number, it's vertical and your slope is undefined. Really crappy joke for today. Crappy joke of the day is, where do they make pencils? Pennsylvania. I know, it's terrible. I would apologize, but I really do enjoy really bad jokes sometimes. So that is all I have for you. I hope you're all having a great day. Talk to you later.